Hello guys, and now let's turn into the 7.2 section of the trend methods. So in this section, technically, the people, instead of just use for the simple exponential methods for just do the forecasting, they now turn the forecasting into the two different parts. The first of all, the level equation, and the second, the trend equation. So they have the two components of the level, the same they apply for the exponential smoothing, simple exponential smoothing. But now they also they form a new function, a linear function with a trend equation. So the trend now, when they go up, they will have some impact into the forecasting of the future values. And when we run it on R-Square, actually, I just recommend you guys to run it right here on the R-Square, ARM Studio, and also for RabbitMiner. We have a kind of an excellent effect. Instead, if you run it on Excel, they still can do it, but there's some bit disadvantage. So that's the reason why we still stick for the color programming language right now. Okay, so in this session, we going to use for the second part of the example. Okay, so one more time, I will use the AUS air dataset. That's the air transportation of the passenger into Australia. So this will be all the annual air passenger from the 1970 into the 2016, right? Okay, and if you really want to have to just explore for the data. So one more time, air. Okay, this all the data include for like 47 observation, and also I want to see for the tail of the AUS air. Okay, the same, right? This will be all the last 6 observation of that one. Now let's go and apply for the horn linear trend method for the next 5 periods forecasting. Okay, how can God get to do it? So I'm now because actually if I do it for the air plot, apply in for the AUS air. Okay, let's check and see that it really can create a very good one. So we have a clear trend over here. So with that, we cannot just make a flash forecasting like the same simple exponential smoothing method that we do in the section 7.1 before. But however, now we have to include for the trend. But however, the trend have some kind of more significant pattern from the 1990 into 2016. So with me, I think that will be better for me to just subset for the window. Okay, the start from the AUS air. Okay, and it should start from the 1990. Okay, that will be it. And I have the data over here. Now I want to do it and check it a little bit. Auto plot. Yeah, the trend now is much clearer. Okay, and the purest window for the forecasting is more narrowed. That should be better. Okay, now I apply for the forecasting model. Remember about that, I will just use the horn function. That will return for the forecast in the exponential smoothing forecast apply. Okay, and we have the different kinds of sections. So like we have the simple exponential smoothing that we already used before. We have the home, and we have the Holt-Winters. Okay, so 3 of them will be the 3 main types of the function we going to just use this in the section from like 7.1 into like 7.3. Right, now let's do it. And home. Okay, I apply for the air data, and I want to use to forecast for the next 5 periods. So it's basically will return for this kind of result, okay, and you see like this going up because of the trend. All right, however, I feel like that's good, but okay, I will just do it one more time, but with the like highlight operation, and I want to summarize them. Okay, I want to see all the function, and I show you over here. They will tell this will be the Holt method for the exponential smoothing, and they create not just only the initial alpha, but also for the beta and the initial state of the L and B. Sigma will be the like standard deviation of the residual we'll not talk about, but the same we return for the criteria of selection and also the error term. Alright, okay, now because that we can do it and we can generate for the result, so I apply for the same, but now I want to plot the result. Okay, the result, and I'm going to apply for the auto plot function. Okay, and if you really want to see it, you can plug in into the YLab. So YLab over here, I'm not sure. One more time, we have to check about the pattern. So like in million, okay. So over here in the YLab, like million number of passenger in million, okay, and in the XLab that should be in year, okay, and how it look like, okay, right, it look like over here right now. It's not like just a flash forecasting that we already do before. If you still remember, for example, in the previous section when we talk about the plot of the oil data, okay, and we already do it for the summary. For this one, you see this is flash forecasting. However, when we jump into the Holt method, that will be a linear upward trend. Okay, so that's the reason why I say about this. Okay, all right, let's do it with the more appealing model. So let's do it with the advanced methods. Like I say, what will be the trend method, but with a dam. Okay, the trend method with the dam. So with the same way, now let's check it, and I do for the forecasting. Okay, so I one more time use for the air data, and I apply them for the Holt with the x equal to 15. Okay, and this is how I forecast for the next 15 period. Now let's say this into an object called the FC. Okay, Holt. Okay, this will be the first one, right? The second one, now I want to apply it with the Holt function also, with the add data. Okay, however, with the Holt function, beside of the clarification about the next periods of 15 periods, I also declares about another function, including for that I want to include for the dam equal to true. Okay, so because of sometime when I feel like what I just run for a linear forecasting like that, they will be just kind of over. Sometimes they will be over forecast. So I really want to just do it with the another function with the dam. So that make my forecasting more smoother, and they will be more reliable and more realistic compared to the exponential Holt method. So what this is what I want to do, and I declare about the fee. Okay, sorry, phi equal to 0.9. Okay, and then I run it, and I have this one. Compared to the previous section, you can see like my forecasting with the previous one, that will be always a little bit smaller compared to the linear Horn exponential training. Okay, so this one 2017 and 2013, this will be all bit smaller there. Okay, right now I'm going to save for that, and I will say apply Horn then. Okay, now let's plot it and compare the two methods. I will do for the auto plot you with the original data. Okay, and I would say that should be series, name that should be original, or I would say like actual data. Okay, and then I apply for another layer. So with another layer, auto layer, okay, that one way, I apply it for the my FC Horn. Okay, and in this, the series name, I would say the Horn method. Remember, clarify about the PI. Okay, prediction interval equal to 4. Right, so this could be the actual data compared to the Horn method. Now I want to change it a little bit, so I add into another layer. Okay, so auto layer and FC Horn, then series, then Horn method, and the prediction interval will be equal to 4. This is how it looks like compared between the three. Okay, of course you can welcome into could insert for some other kinds of action. All right, you are like, for example, over here I want to add for the CG title, and also I want to add for the X level, the Y level, and I want to change for the title of the legend into the forecasting method. Okay, now that should be what it looks like. Yep. So basically you can see the forecasting method between the two ways of the Horn linear methods and also the dam Horn methods. The dam Horn methods will be more reliable, right, and it look more realistic, and that will be the advantage of the dam Horn methods compared to the original train Horn methods. Thank you so much. So after when we already have talked about the whole trend method, sometimes the data itself is not only just go with the trend, right? It's not to talk about the data go up or down, but also at the same time they also express with some seasonalities. So in the case like data, they have the seasonalities. That could be the time for us to apply for kind of like attention model of the symbol trend methods of the Horn model. And that should be what the people call about the Holt-Winters seasonal methods. Basically, we have the two forms of the seasonal methods. They add it just not only for the level, the trend, but for the seasonal component patterns of the time series. And like with the same periods of the time series decomposition method with the additive and the multiplicative methods, the Holt-Winters season, they also apply for the same with the additive methods, which will be more stable and also appropriate for the time series with the constant variant in the seasonalities, while the multiplicative model would be more stable and thus will be better for the data sets with the kind of like upward or the change in the variation of the seasonality over the trend. So we're going to apply it in the R Studio. First of all, I want to introduce you guys for using for the AUS tourist data. This is the international tourists into Australia for the total visitor 9. So that's quarterly visitor 9 in million span from 1999 into 2005. And that would be better to just explore the data. Okay, so we wanted to see it SGR for the AUS tourist. That's a time series with 68 observation. Now I'm going to use this one more time, but I want to apply for the auto plot. I want to plot for my data. So look over here. You see there was a pattern of the fluctuation, right? For the fluctuation of the seasonalities. However, it looked like for all the data before the 1999 into 2005, even when they had the seasonality pattern is not so stable, and they fluctuate and not so clear. It would be better for me to just redone it, but all the data just should be start from 2005. Okay. Another pattern we can observe would be like the seasonality, they varies over time. With the later periods, with the greater trend, you see the variation in the fluctuation of seasonalities be larger compared to the beginning of the period. So in this case, the multiplicated methods will be more suitable. But that's just like my first impression. Let's check it with the later data. Okay, so my first idea would be like subset the data. Okay, just from 2005 only. So I want to do it and use the window function with the Australia tourism data. Apply for the window, and it should start from 2005. Okay, this is my data from the first quarter of 2005 into the last quarter of 2015. Alright, now I say it all in object called AUST, and now let's go and apply for some model on that. First of all, the Holt-Winters additive seasonality. Okay, so we gonna just use it for the Holt-Winters function. If you really want to see what is the Holt-Winters, you can go and check it. But I already tell you with the Holt-Winters, we can use for seasonality, and we clarify about that will be additive or not additive, but the multiplicative. We can also apply for the dam or not, exponential or not, and everything else. Okay, but now I would just automatically use this for the Holt-Winters, applying for the data of Australia that I already subset before. And I also want to just clarify about seasonal equal to additive. That's in my forecasting, and I want to save it in the Fig 1. Okay, that's my third model. Now let's do it one more time, but now I change for the model into the Holt-Winters, but for the multiplicative seasonality. Okay, and Holt-Winters. One more time, I want to clarify about seasonal. That's equal to multiplicative function, and I say it into Fig 2. Okay, now this would be the time for us to maybe in some way you can summarize the data of the Fig 1. You see what will be the result. They already generate for the alpha, beta, and gamma. That will be the clarify for the level, the trend, and also for seasonality. Okay, and you can also see about the criteria of selection and also for the error measure. Okay, the same thing I can go and apply it for the 7.2. Okay, Fit 2 model and go in this way. So with me, over for all these guys, I can go and compare between the two models, and it looked like with me the multiplicative compare when I see for all the criteria of selection and also for the error of measurement. It looked like the second model a little bit better. But let's go and check it, right? Let's go and check it for another way. So I will plot and compare the two models. Alright. So I use autoplot, and with the AUST data, the series name, I would say that would be data or actual data. This would look like this. Of course, I can add for auto layer. Okay, and I want to put into Fit 1 model with the series name equal to what the Holt-Winters additive forecast. Okay, and I want a prediction interval equal to 4. That's the second layer. Okay, there's some problem about this one, an error. Okay, this will be over here. Okay, anyway, I want to add for another layer, but auto layer and add in for Fit 2 seasonal, but now multiplicated. Multiplicated forecasting with the PI, and also I want to add for the X level. This would be year. The Y level, this would be visitor 9 in million. Okay. If you really want to add for the CC title too, I would say this will be international visitor 9 in Australia. Okay, and I want to change guy. Okay, use the guy function, and I want to change for the name of the legend. Okay, so title here, I want to change them into the new one. That would mean the forecasting method. It look completed. Here, over here, you can see this with the color, the blue line. This will be multiplicated model, while the green one will be the additive model. Right. Now, let's go and do it with another section. So basically, we can also apply for the Holt-Winters method with the dam. Okay, so with the same way, I apply for the Holt-Winters of the Australia tourism. Now I clarify with dam equal to true. Okay, and the seasonality that's equal to multiplicated. Method, and that's my result, but I will call them will be Fit 3. Okay, and one more, I add for this layer. Okay, I will copy for this kinds of video all the codes, and I add for another layer. So auto layer fit 3. Series name equal to the homework with them, Holt-Winters with them, multiplicated, forecast, okay, and plus. Now it changed a little bit, but like everything will be look fine, okay, and I run it on one more time. Okay, of course, like we had the prediction interval, so prediction interval will be 4, 2. This is how it look like. This is the, especially the purple one, okay, they even make it much better than the multiplicated forecasting. That will be the way for it to run it on. Okay, and in anyways, I already run it for another examples, but over here I will just copy for the code and you guys can follow it. So the Holt-Winters method with the daily data. So we gonna just take an insight into the Hitman block, and he grow and collect the data from the April 2014 into April 2015, the daily data. Okay, and with this one, when the people do it, actually the data over here, they run it, they do the subset for the data, but they just use the rest for the 35 observation later for prediction. Okay, and then later they apply for the Holt-Winters with the dam, and the seasonality will be the winter plicated, okay, for the next 35 observation. Okay, and then they plot it with the auto plot, and they do it all and apply for all the things into the same layer. So we compare it, and we will see this could be seasonalities and how it looked like compared to the real data. Okay, thank you so much.